assignment 3. Today I will present about my assignment. Uh, First of all, I will run the code that are already made for me. This is a template. First of all, I will import the necessary packets and library. Then I will get the image and then visualize the image here for you. Then I will transform the image into 3D array. Next, I will show the image. As you see, this is the Lamborghini. Then I will print the array, shape the array, and compare the value of color channel 0 and channel 1. Also, compare the value of channel 1 and channel 2. As you see, it's not equal. Then I will save the color channel 0 into the input image array and print it. As you see, I will set the color channel, the last digit here to 0. So you see this RGB return to 0, so it's no color. It's only the yellow color and the green color, not like this one. Next, I will create a bar array by adding 2 rows, 2 columns. Next, I will create a kernel. Then I will create an outputs array. Then I will compare both the arrays. We see here the difference between the original array and the padded array shape, and apply the kernel to the array values. As you see here is a new image. Then I will define the standard, the swatch pixel value function here, and define the 2D kernel image. Next, we will create a kernel that detects the horizontal lines. This is the value that show the horizontal lines and apply to the image by using the con to the kernel. The first value is the input image array we already declare on the top. Let me see. This here, yeah, this one, input image array. We already declared and we use to apply the kernel horizontal lines into it. You see here, we specify the kernel is a horizontal kernel, and we show the image here. The question is we will create a 45-degree of lines. So after research online, I saw the digits here that implements the 45-degree line, and I apply it into the image by using the com2d kernel, and you see the image input. The kernel here I specify the degree 45, and I show the image again here. And for the next question, you see the 135 degree, and I use the same one, but I change the number here into the 135 degree, and I apply into the image. The question 2, we will apply the kernels that predefined first. So we use the same function to apply it into the image. On the same here. And for pack 3, I will import on this library, but for minor change, because the default one I couldn't run, so I add in some TensorFlow, so it can run. Next, I will load the dataset from the CIFAR 10, and I will change the categorical gen labels and change test label, and change the type into the float 32 also normalize by divide it to 150 by. Next, we will build the neural network model. We will specify the sequential, and they have some layers here. We will compile using optimizer, Adam, loss, categorical catastrophe, the matrix accuracy. This is the summary of the model we already defined. This one is the custom callback class. So after 5 epoch, they will show the message, the finish epoch, accuracy rich, and accuracy rich value, the chain and validate. And next, we will chain the network with the chain image and the chain labels. So after runtime, we will plot the result here. First of all, we will define the function that plots the result. So I plot the result here. So the question is it overfitting? So yes, it was. So after I believe it in epoch of 10, they will they have the size of the overfitting here. So you see the validation accuracy is not no more change. It's just in the same way here. So it's the overfitting. So how many layers in the neural network that we run? So it's 5 layers. You see here. First of all, the con 2D. Next, the max pooling, flatten, dense. They have 2 dense. So totally we have 5 layers. For next question, so what is the purpose of each layer? So for con2D layers, it creates a convolution kernel that is convolved with the layer input to produce the tensor of outputs. For max pooling 2D, calculates the maximum or the largest value in each patch of each feature map. Flattening is converting data into one-dimensional array for inputting it into next layer. And for dense layer, is used to classify image based on outputs from the convolutional layers. Next, the question asks us to add more convolution layers. So I will add more convolution layers, and I also change to 64. And then after I compile it and fit it, and I plot the results here. As you can see here, so after we add one more convolution layer, they reach the high value of validation accuracy and training accuracy very fast, not like before. They take some time to reach this value, but for adding one more layer, they have reached faster. Next, the question is we add the dropout to our model, and I add the dropout model here after before the dense, and I have read the book that we cannot add the dropout. We shouldn't add the dropout before the last layer, so I add the second last layer, and I compile the network and also fit the network to train the network. After 50 epochs, you can see here it's reduced the overfitting. That's right. You can see before at the epoch of 10, it will show the side of overfitting, but right now you can see it shows the side of overfitting over here. So it's about 15 or 14 epochs. So it will reduce significantly the overfitting. So how it works? So basically, the dropout layer is one of the most popular used regularization technique for neural networks. The main purpose of using dropout is overfitting reductions, and basically dropout is added to layer, which it drop out randomly some output features of the layer. So by drop randomly some features, the output of feature will be shuffled. They not the same Python, and then this will reduce the overfitting problem for us. Next, ask me to modify some hyperparity parameters to improve the accuracy. So as you see, I only add job out. So right now, I think I will add one more layers to change the hyperparameters. And I run it. Yes. So if I add one more parameter here, the overfitting also reduced, and the accuracy and chaining accuracy is increased too. So it will improve the accuracy. Okay, thank you for listening my assignment.